All right, so moving on in integration stuff, we are talking about use substitution for integration. So, guys, just by the name alone, let's see how your brains work. Why would we even substitute anytime? Why do you substitute things? So substitution usually implies that it's easier, right? I can if something they're equal, right? That's when you substitute. If this is equal to that, then I can substitute it in, and with bless you with integration, hopefully my thing is hopefully I can make it easier for me because so if you've noticed so far, all the stuff we've integrated have been relatively simple, right? They've been relatively simple equations um, that you're just literally just adding and subtracting things, right? You might have to do some uh, maybe rewriting of the equation before you integrate, but for the most part, they've been relatively simple. Usually one quick step. So if you, so obviously, most expressions, equations are not that simple, right? Sometimes they look complex, they look harder than they really are. So this is where use substitution comes in for integration. All right. So far, after the last session, we should know how to do some of the following integrals, right? And let's just make sure you do understand how to do. Like, how would you do this one? So you would change it to x to the 1/4, and then when you actually integrate it, it would become what? 5/4, and then you would change that to 4/5. Everybody got that? Don't forget your plus c, right? How would I do this one? So it become t to the -3. Then when I integrate it, it would be t to the -2, and what would have to be here? -half. Right? We haven't talked about this yet, but it makes sense because, okay, what am I really asking here? The derivative of what is cosine, right? So then what is the antiderivative then of cosine? It would be sine. Does that make sense? Right? Because here what I'm asking is, like, here's, remember, this is your derivative. So what was the original? So exactly what, the way we're saying it's the derivative of what is cosine. And our answer is sine plus c. And then finally, one of your rules, the integral of e to the anything, e to the x, e to the w, e to the y in this case is what? Itself. Everybody comfortable with those? Okay, so trig is probably the one we didn't almost talk about at all, but it makes sense. Remember, it's those rules, right? You just have to know those rules and then think about them backwards. Good? So, this one? Yes, my bad. You put plus c on all of them. Right now, guys, there's going to be a time where these are called indefinite integrals, meaning they're not defined. There will be a time when they are defined, when you're going to have what we call limits on your integral. Once we get to that, you no longer have to put plus c because you know the actual limits of the equation. But right now, without limits, you always have to put plus c. Okay? All right. So, everybody's comfortable with these, right? What if I gave you those? Looks crazy. Why? Tell me why these look crazy. You guys see that? You guys see how there's multiple things being multiplied? There's some things being divided, which means I had what kind of here? Quotient rule, right? And then and it looks way more complex. So obviously our simple rule of power, our simple power integration rule is not going to help us with those things, right? So we have use substitution. It's called use substitution. So now I'm going to teach you how to do something like this. It's called use substitution. Okay? Use substitution. All right? So what you have to do is to be able to recognize things in your expression. So what you're looking for are two expressions. Okay? Two expressions. And you're hoping that one of the expressions is the derivative of the other. So, first of all, I need you to recognize that there are two expressions here. You guys see, here's my first expression, and here's my second expression. Notice what I didn't take into account. What? The radical, right? I didn't take the radical. Why? Because that's going to make my job a whole lot harder. Okay, so just think simple. Does everybody see my two expressions? Okay, so just looking at those two things, is there one that's the derivative of the other? Yeah. 6x cubed plus 5, if I were to actually derive this, what's the derivative of 6x cubed plus 5? 18x squared. So this is the derivative of this. Does everybody see that? Good. So what you do at this point is you say, look, I'm going to call u my original expression, which is going to be the 6x cubed plus 5. And then think about it this way. What do you think I mean when I write this? Derivative of u. Okay, so what is the derivative of u? But notice, look at your equation. It has a what? What variable? An x. So it's the derivative of u with respect to x. So what's the derivative of 6x cubed plus 5? 18x squared, but because I took a derivative of with respect to x, I have to write dx. Does everybody see that? Now, why? That's important. That's very important. Because look, I'm going to substitute something, which means I'm going to what? Replace. And I want to try and replace as much as possible. What I want to notice, I have a 18x squared, I have a 6x cubed, and then I have a dx. You guys see these three different things, right? And obviously I'm going to replace it with u's, correct? You don't want a u and then leaving an x in there, because then you're going to have to deal with two variables. So you want to replace everything. So what I'm saying is that these two things are together. And I'm going to replace those two things with a du. Okay? So here's how it's going to look now. I'm replacing everything. So I have the integral of the fourth root of u du. Does everybody see that I perfectly replaced everything I had? Okay, so this was my u, so I have the fourth root of u. And then my du counts as my what? My 18x squared dx. You have to take that dx into account. Does everybody understand? That even that dx was replaced. Okay? So now a lot of students get confused. Guys, they're not written together, but can they be together? Yeah, because everything is what? Being multiplied, so order doesn't matter, right? You can move stuff around, shuffle things around. So now, does everybody see why I use u substitution? Doesn't this look like a lot easier for us to integrate? Because as a matter of fact, here, I can just say, oh, this is actually u to the 1/4 power. And then, because I only have u's, I'm going to just do this with respect to u. Okay? So very simple now. So now, integrate. So it becomes u to the 5/4. 4/5 is going to come up front. And then I still have, of course, don't forget my plus c. So that's technically my answer. I'm done, except one small problem. My questions was in terms of what? X's, and my answer right now is in terms of u. But it's okay, because if I substitute it once, I can bring it right back. So what I'm going to do now is say, this is really 4/5 6x cubed plus 5 to the 5/4 plus c. You got to put that x back because that was what the question was in the first place. So u substitution is basically the tool, right? It's the tool that you're using so that you are able to integrate, but then you still have to answer the question in terms of x. The x, yeah, because u is this, so and you said earlier that u was 6x plus 5, so replace your u. Does everybody see how this is going to kind of work? Okay. So, yeah, so okay, you know how when we normally integrate, all this means is that you're going to integrate with respect to u. Right? And remember, it was the parentheses. So it's like, here, just integrate everything in between these things. The reason you have this tells you what variable you're using. Okay? This tells you what variable you're using. And it's okay because my equation only has the u variable anyway. Okay? You sure? So just like before, when we were doing these, they all had dx's. That just told me integrate with respect to x. Basically, your answer is going to have nothing but x's in it once you integrate, okay? That's all, and that's all we did. dw, dt, dy. It's there. I don't want to say ignore it because it is important. Because if you ever had something that looked like this, x squared dy, you can integrate that, right? I mean, you can. It's kind of like implicit. But you can't just do your regular old integration, right? Because this equation has an x, but you're supposed to be integrating with respect to y. You see what I'm saying? So it does impact your question, but as of right now, um, you're kind of not ignoring it. It's just your regular parentheses. But I had to. Here's my thing. Here's what students will always forget. They'll forget about this. Okay? They'll forget about this. They'll just think it doesn't exist. And they'll have the right u, they'll have the right du, but then you're technically forgetting about the dx. So when you substitute and you don't replace that dx, you should write it. You see what I'm saying? You can't just ignore it. You should write it. But it's not supposed to be there in the first place. Okay? So here is the rule that we're following. Here's the actual formal definition of u substitution. It says this. If the integral of f of g of x, meaning what? What does this mean right here? F of g of x. G is in f, right? G is the x in f. And then, does this look familiar? This is my chain rule, right? This is, well, kinda, because the chain rule, actually, you would have to have a derivative here, right? So this looks very similar to my chain rule. So so it says this, f of g of x times g prime. Basically, there's a derivative of the inside part, right? And then it says is equal to f of u. I'm not trying to cuss you out. That's just the way it's written, okay? The integral of f of u du, okay? As long as u is g of x. So the good thing about this is you establish the u. U establish the u in this. So you can have it be whatever you want. So you can. That's a lot of u's, huh? So you can yourselves can make it whatever you need it to be, whatever you need it to be. Now here's a very, very important fact. I need you to write this down. So we need to point out that often, in fact almost in every case, the differential will not appear exactly in the integrand as it did in the example above. And sometimes we'll need to do some manipulation of the integrand or the differential to get all the x's to disappear in the substitution. So you know how in the last one my u was 6x cubed plus 5, right? And then which was nice because my du was 18x squared, which was exactly what it was. I'm trying to tell you this. It's not always going to be like that. It's not always going to be exact. So you are going to have to do some manipulation. But I'm going to show you how to do that too. Okay? So I'm going to give you a couple seconds. You really need to take this in the heart. Write it down if you have to. And here we go. Okay, so let's get some more examples going. Here we go. So I have the integral of 1 minus 1 over w cosine of w minus ln of w dw. Okay? So this one's nice because they kind of put parentheses around your two expressions for you, right? They kind of put, so do you see your two expressions, right? So which one is the original? Which one do you think is the derivative?
So that one's
On the left is the original?
no.
Yes. No. No. Because the substitution itself is simplifying, right? So do y'all see an original? Probably this one, right? So looking at this, what's going to be the derivative of this? Just the w minus ln of w. Which is that. So you see how this, then I'm going to establish this is my u. Whoop. This is my u is w minus natural log of w. Therefore my du is what? 1 minus 1 over w dw. Remember, the plus c is only when you're integrating, and right now I took a derivative. Yeah, at the very end, once I've integrated. We good? So then tell me, So I'm putting these two together again, right? Those two together. So then what is my new integral? Cosine of u du. Is that simpler? Now I only have to deal with one operation here. And so then question is, well, what's the integral of cosine? Sine. So it's going to be sine of u. What am I forgetting? I just integrated, right? I just integrated. So um, I have to put the plus c. And then is that my final answer? Now I got to put my u back. So the actual equation is sine of w minus ln w plus c. Let's check to make sure we're right. So let's check to make sure we're right. How would I check that? Take the derivative of this. So that means that here's my original. My original is sine of w plus ln of w. Okay? And then I can add a constant. It doesn't matter. It's going to go away, right? But so then here would be, you're saying this is your original. What would be your derivative? Or, I'm sorry, f of w, whatever. So what rule would you have to use here? You would have to use the chain rule, right? Because you would have the derivative of the outside with the original inside times the derivative of the inside. Agreed? So what's the derivative of the outside? So it would be cosine of the original inside. And then you're going to times the derivative of the inside, which would be what? You guys see? Which one? Did I? Oh, I wrote it wrong. My bad. My bad. Well, no, because you took the derivative with respect to w. The dw was understood. No, we're not. I'm not asking you to check every single one, but I mean, you can, right? You can to make sure you did it right. So does everybody see how this works, right? We're basically doing in these cases, it seems like we're doing the opposite chain rule, right? We're going backwards. We good? Okay, let's kick it up a little bit. So the thing, your initial reactions? I'm hearing them. What are your initial reactions? This looks crazy, right? This looks crazy. But then once you write it, you're kind of like, what are you looking for? You notice that when I start my work, when I actually start the process, I'm not looking at it as a whole, am I? I'm starting to observe the pieces, correct? I'm starting to look at the tiny parts of it. What makes this equation? So, I have 3 parentheses 8y minus 1 times e to the 4y squared minus y dy. Now, this e kind of throws people off, but guys, remember, it's actually the simplest one, because if I can leave it there, e to the anything, the integral of e to the anything is what? Itself, right? So, good. So does everybody realize that here's my u because there is my du, correct? Here's my u because there's my du. So if I say u is what? And then my du is what? 8y minus 1 dy, because I just took a derivative with respect to y. Okay? Now there's something, so I see this is being replaced with a u. I see this is being replaced with a u. I see this is being replaced with my du. What's the problem? There's that 3. There's that 3. So let's look at it. So the way I wrote it, it's going to look like this. 3 e to the u du. You good with that? So now, what do you think I could do with that 3? It's a constant. Remember, like with before, one of your integration rules says if you have a constant times a function, just bring that constant out. Don't worry about it. So basically, I'm asking you to do this. I mean, it's still going to be there. It still has to come into play eventually. But as far as integration, I'm not really going to worry about it. Does that make sense? So then here, do your integration. This one's a lot easier now. What's the integral of e to the u? e to the u. But I still have that 3, so it's actually going to be 3 e to the u plus c. And then, of course, finally, my last step is to do what? So 3 e to the plus c. Does everybody see how this is going to work? Not too bad, right? Not too bad. We good? Okay, let's kick it up a notch. So we got to climb this ladder, people. We got to climb this ladder. Okay? So, I have the integral of x squared, parentheses, 3 minus 10x cubed to the 4th power dx. X squared, parentheses, 3 minus 10x cubed to the 4th power dx. Yeah. So, what do you suppose my u is going to be? 3 minus 10x cubed, what's the derivative of that going to be? It's negative 30x squared, but I only have a what? An x squared. So you see how this one, remember I told you, it's not always going to appear exactly how it is. But you see that's pretty much my only option. Because I can't say, well then maybe this is my u. Because what's the derivative of x squared? 2x, which is definitely not going to be something x cubed. You see what I'm saying? So at this point we're it's pretty established this one has to be your u because at least you have the x squared part right. You see what I'm saying? So here we go. What's my u going to be? 3 minus 10x cubed. You with me? So therefore, what is my du? Negative 30x squared dx. Now, again, this is what I told you. It's not always going to appear exactly, so sometimes there's going to have to be some manipulation. What's the problem, bless you? So what's the problem with my du? The negative 30, right? Because I don't have it there, so I can't just replace it because it's not there. Does that make sense? So what I'm going to do is, so what is there? My x squared dx. So basically I want this to be alone. So get rid of the 30, the negative 30. Good. Divide or multiply by the reciprocal. So do you guys agree with this? That negative 1/30th du is equal to x squared dx. Right? Does everybody see what I did? So I can replace this, the x squared dx, with this. Okay? I can replace that, the x squared dx, with that. So what is my integral going to look like? It's going to be the integral of, we can put that to the back. So let's just figure out this. U to the 4th power, but then remember, it's times negative 1/30th du. Now you might think, well, that 1/30 is throwing me off, but guys, I can take it out. It's just a constant, right? So then what I can say is, look, I can just have my 1/30th on the outside, and then it's just u to the 4th du. That's much better. That's much better. I can deal with that. See how that's going to work, people? See how this is going to work? So once you come in, this is most like most problems, where it takes some manipulation of this, right? So far it's been, it's real nice. They're exactly how they are. They're going to substitute perfectly, but it's not. It's usually something like this, where you're going to have to manipulate to get what you need to be replaced by something else. Okay? So then now you can just integrate. Okay? So my negative 1/30th is going to stay, but then now let's do my integration. This is going to become u to the what? U to the 5th power. And then times 1/5, of course, plus c. And then now, can I simplify this? Yeah, because this is just two fractions being multiplied. So this is going to become negative 1/150. And then put my u back. Does everybody see how that works? Yes, no, maybe so? I need you to understand this part, more importantly than anything. Because remember when you integrate, were you here for that? you have to counter the front, right? So you know that 5 times this 1/5 will become my 1 that I need here, right? So this is just this part. We good? Any questions so far? Are you sure? Because I'm about to let you loose, no? Okay, let's try one more together. Oh man, this one sucks. Does it? We'll see. I don't know, maybe we can make it easier on ourselves. So I have the integral of x over square root of 1 minus 4x squared. So this looks like it's a what? This looks like it's going to be a quotient, right? But we've been doing backwards chain rule this whole time. But guys, remember, you can always rewrite stuff. So let's rewrite this to maybe look like a chain rule. So what am I going to have to do? Move the bottom to the top. Can I do that? Yeah. If I do that, what's it going to look like? X times 1 minus 4x squared to the negative 1/2. So yeah, does that look a little bit better? At least we don't have to deal with the quotient, right? Okay. So then now, this one's also kind of one of those, oh, I'm kind of stuck because I only have one option. Which one do you think my u is going to be? The 1 minus 4x squared? So if u is 1 minus 4x squared, what's du? Negative 8x dx. What's the problem? That negative 8 is the problem. So deal with it. How? Du over negative 8, or? Do you see why I want it as a fraction? Because then it looks like a constant, right? Because if you try and write that over there, it's going to look like du over 8, which is weird, but negative 1/8 is easier to move out. Everybody good with that? Okay, so what's my new integral? I can pull out the 1/8 now. Is that okay? Pull out the 1/8 now, and then I'll have what left? U to the negative 1/2 du. We good? Okay, so now integrate. So that negative 1/8 is going to chill for a little bit, and then I know I'm going to multiply it by my integral. What do I do to integrate this one? It's going to become u to the 1/2, and then I'm going to counter it with a 2, right? Plus c. And then now, simplify. It's going to become a what? Negative 1/4. Put your u back. You guys ever think about if somebody walked in, what they would think when they look at the board? I always think about that. Oh, anytime I get a walkthrough, I'm always like, do you really understand what we're doing? Or is it just you? Yeah, that's what. It's funny because you said earlier, I'm totally recording this, but whatever. Uh, you said earlier how you feel like you guys have to think less or not think as hard, right? Because y'all have Google and stuff like that, and computers and stuff like that. But it's weird because it also has come to the point where like most of your parents can't help you because they never took calculus because it was not even required, right? It wasn't even like an option. Like I know my dad, for instance, um, the furthest he ever went in high school was algebra 1. Like that's all that was there. They didn't care about anything past that. But then now here we have algebra 1 is ninth grade, and then geometry, and then algebra 2, and then pre-cal is that's like the minimum now, right? Pre-cal is like the minimum. And I'm thinking, geez Louise, I mean, it's funny because my own dad, he took college algebra, he had to take it 4 times because he kept getting a D, and D's not passing. So he was just that's why he's weirded out by my math brain. He's like, how do you get that? I'm like, oh. And it's just, yeah. I'm dreading that. I'm dreading because they're moving up those new calculators. They're basically like computers, and I'm dreading them coming up to me, and I'm like, I don't want them. because I know that I'm gonna be like this, and they're gonna be like, huh? You know, how do I put that in the calculator? Yeah. All right, guys, let's finish this off by you trying a couple yourself. What do you mean? Oh, you can. It doesn't matter. I mean, you want to put this as a square root? You can. It's not gonna change. It doesn't change your answer, right? So you're saying you want it as negative 1/4 square root of 1 minus 4x squared plus c. At this point, guys, I don't care which one you give me. I just need you to understand that there's the two options. You know what I mean? Yeah, that's what I'm saying. Like, I don't want you to see, oh, this is not one of my answers, but this is, and freak out. You know what I'm saying? So you guys, at this point, I feel like you understand. They're, if it's free response, they'll take both. They'll take free response. Yeah, if it's free response, they'll take this happily, because exactly what you said. It's time, so you know, simplifying is not on the yeah. Yeah, you can do stuff like that. As long as it's mathematically true, they can't count it wrong, right? So, all right. So let's do. Why don't you try a couple of these? I'm gonna give you about 8 minutes. Okay, I'll give you about 8 minutes to try those. I'll walk around, help you out, help each other, and then we'll come together and see if you're right. Here we go. For this first one, I have the integral of 8x minus 12 parentheses 4x squared minus 12x to the fourth power dx. What's my u in this case? What's my du then? Oh, this one's nice then, right? So then what's the integral? So then what's my answer? Plus c, and it becomes 1/5 times 4x squared minus 12x to the fifth plus c. Say that again. Yeah, just remember, it has to be there at the end. Good? Okay, for the next one, I have the integral of 3t to the negative 4th, parentheses 2 plus 4t to the negative 3 to the negative 7th dt. What's my u in this case? What's du? dt. Is there a problem? It doesn't match, because I need a 3, but I have a negative 12. So then? Negative 4, right? 1/4. Yeah, because you're dividing it by negative 4. So you're going to multiply by negative 1/4 du is 3t to the negative 4 dt. Does everybody understand that? Because I need the 3. Yeah, I want to try and replace that 3. Right? So because I'm trying to get this negative 12t to the negative 4 to match, if I can. Right? So then now, what do I have? Negative 1/4 integral du. So here's my negative 1/4 du, and then here's my u. You got that? So then now integrate. So that negative 1/4 is going to stay there. And then what's the integral of u to the negative 7? So it would be negative 1/6 u to the negative 6, of course, plus c. And then now simplify, it's going to become what? Well, they're both negative. 1/24th. 2 plus 4t to the negative 3 to the negative 6. Good? Oh, be careful, because it's not the same. Last one. I have the integral of 90x squared sine of 2 plus 6x cubed dx. Okay, so what do you suppose my u is going to be this time? To the third. What is du then? Okay, what's the problem in this one? It's 90, and it's 18, and I need a 90. So this one I'm actually not going to divide. I'm going to multiply. I need it bigger, right? So what do you have to multiply 18 by to get 90? 5. So 5 du is equal to 90x squared, which is what I need to be replaced, correct? So then what is my integral? 5 integral sine of u du, because the sign stayed, right? And then now integrate. 5 is going to stay. What's the integral of sine? Or basically, what am I asking? What derivative gives you sine? Because what's the derivative of cosine? Negative sine, but it's not a negative. I need it to be positive, so it's actually going to be a negative cosine. Very good. Of u plus c. And then now simplify. This is just going to become a negative 5 cosine of 2 plus 6x to the third power mas c. Spanish minor right there. Any questions about u substitution? Do you understand why we have u substitution, right? Because I can take something that's very complex, make it simpler for me. The only part that the work that I have to do is figuring out what's my u, what's my du, do I have to manipulate, and all that for I need basically perfect substitution. We good? Any questions? We go with u substitution? Fantastic.